Hey all, today we're going to talk about pairs of angles, and we're going to talk about linear pairs, vertical angles, and then what happens when two lines are intersected by a third line that we call transversal, and the type of angle pairs that get made there. So let's talk first about linear pairs and vertical angles. So vertical angles are formed whenever we have two lines or two segments that intersect each other. And so what we end up with are two pairs of vertical angles, and they are sort of across from each other. They share a vertex. So the vertex of angle 1 and angle 3 is right there. But what they don't do is share a side. So angle 1 has these two sides, and angle 3 has those two sides. So they share a vertex, but they don't share a side. We call those vertical angles. And we know something about vertical angles. What we know about them is that they're congruent. So a reminder that this symbol right here, the equal sign with the squiggly on top, means congruent. That means they're the same measure, they're the same size. So angle 1 and angle 3 are vertical angles, they're congruent. Angle 2 and angle 4 are also vertical angles, they're congruent. So if we know angle 1, then we know angle 3. If we know angle 2, then we know angle 4. What we also have are linear pairs. You might think from the word linear that these two angles make a line. So I have a bunch of linear pairs here. If I look at this line, and then I look at angle 4 and angle 1, when I put angle 4 and angle 1 together, they sort of create this straight line together. And a straight line is 180 degrees, so we know that linear pairs, their measures will always add up to 180. And in fact, in this picture, we have four linear pairs. Linear pairs don't always have to come in this way. Sometimes we will just have something like this, where I have two angles, that one, and together they make this straight line. That's a linear pair. But in this picture, we have four. So we have angle 4 and angle 1. We have angle 3 and angle 4. They make this straight line. Angle 1 and angle 2 make this straight line. And angle 2 and angle 3 make this straight line. So we have four different pairs of linear pairs here. All of those pairs would add up to 180 degrees. So let's decide whether or not these two pairs, A and B, angle A and B, are a linear pair or vertical. So if they're a linear pair, they're going to share a vertex and they're going to make a straight line. So A and B here share a vertex, and together they make a straight line. So they are a linear pair. Over here, A and B share a vertex, but they don't make a straight line. Angle A is right there. Angle B is right there. They're across from each other. That means they're vertical angles. In this picture, A and B, they share a vertex, but they're not across from each other. They make this straight line, so these are a linear pair. And then over here, A and B, they're sharing a vertex. They don't make a straight line. That's angle A. That's angle B. They're right across from each other. They're vertical angles. So once we can establish what kind of angle pair we have, then we know what the relationship between those angles is. So if I know that these two angles are vertical angles, then I know that they should be the same measure. They're congruent. So if this angle over here is 53, then the one across from it, B, is also 53. Similarly, these two are vertical angles. They're across from each other. They share a vertex, but they don't make a straight line. So they're both 48 degrees. These two angles are a linear pair. So we know that they should add up to 180. So I can actually write an equation that shows that. Angle B plus 128 degrees should be equal to 180. And so we do a quick little bit of algebra, and we find out that angle B is 52 degrees. So now we can take it a step further. We're going to start layering in some algebra. I can establish what kind of angle pair I have here. They're vertical angles. I know that means they're congruent, so they should be equal. So I can take 4x, that represents this angle measure, and 84, that represents this angle measure, and say that they're equal because they're vertical angles and they're congruent. And now I have a algebra problem to solve. I do that by dividing both sides by 4 and determining that x is 21. And if you want to check your answer, you can always go plug it back in. So 4 times 21 is, in fact, 84. These two angles, they make this straight line. So this angle 2x, this angle x plus 21, together they make this straight line, and so they're a linear pair. And that means that they're going to add to 180 degrees. So I'm literally going to add those two angle measures, 2x and x plus 21, and say that that addition should equal 180. I'll clean up this side by combining to 2x and the x to make 3x. And now I can just solve this equation. Subtract 21, divide by 3, and find that x is 53. Of course, that doesn't mean that either of those angles are 53. If I want to find out how big the angles are, I plug 53 back in. So 2 times 53 here makes 106. 53 plus 21 here makes 74. And I do believe 106 and 74 would make 180 degrees, which they should. Let me do one more of these. Again, I have a linear pair. These two angles, 55 and 6x plus 5, make a straight line. So they should add to 180. So I add those two angle measures, and I set that equal to 180. Clean up the left side by combining 55 and 5. And now I'm solving this algebraic equation. Subtract 60, divide by 6, and I get x to be 20. So if I want to know how big this angle is, I can plug x back in. 6 times 20 is 120, plus 5 is 125, and then if I add 55 to that, it makes 180, which it should because these are a linear pair. Just real quick, the other word that we could use when we're talking about angles that add to 180 is supplementary. I think that's probably a word you're familiar with. So linear pairs, the other thing we can say about them is that they're supplementary. So I want you to answer the questions associated with this problem and then move on. I'll give this problem a try as well. The last thing I'm going to talk about in this lesson are what happens when I have two lines like these two right here and a third line that we call a transversal that intersects both those lines. So this line right here is the transversal. What I end up with is 8 different angles that get formed. And they're related to each other in special ways. So what we have created is sort of what we call an interior. So in between these two lines, we would call the interior of this figure. And so I have all 4 of these angles that are in the interior. And so that means that angle 1, 2, 7, and 8 are on the exterior, the outside, not between the two lines. So I have some same side pairs, and when we talk about same side, we're talking about the same side of this transversal. So we have some angles that are on the same side of the transversal, an interior between the two between the two lines here. Sorry. So I have angle 4 and 5, and I also have angle 3 and 6. Sorry, I forgot to write those. They're in the interior and the same side of the transversal. We have same side exterior, so 1 and 8. Again, sorry, I forgot to write that one. And 2 and 7. And in fact, now I'm finding out that I've totally screwed that up. So my interior are 4 and 5, 3 and 6. Exterior are 1 and 8, 2 and 7. And they're on the same side of the transversal. Let's see if I didn't make any mistakes here. We also have alternate. So again, I did both alternate interior angles here. So this goes to show that everybody makes mistakes, but we can roll with it. So my alternate means they're on opposite sides of the transversal, and also they're next to the opposite of these two lines. So I have angle 4 and angle 6. Those are alternate interior, and also angle 3 and angle 5. And then I have angle 1 and angle 7, alternate exterior, because on the opposite side of the transversal, and they're on the outside of these two lines. And so that means that 8 and 2 are also alternate exterior. And the last type of angle pair formed here are called corresponding angles. So if you sort of cut this picture into two groups of 4 angles, one group there, one group there, the angles that are in the same position in each group correspond to each other. So in this case, angle 1 and angle 5, angle 2 and angle 6, angle 3 and angle 7, and angle 4 and angle 8. And I actually got these 4 right, so maybe I've redeemed myself. So let's determine what type of angle pair exists in each of these pictures. So I like to sort of cordon off what the interior is. So in here is the interior between the two lines that are intersected. So I know that A and B are interior angles. And so the next question I need to ask myself, are they on the same side of the transversal or opposite or alternate sides? And what happens is they're on the same side, so we call these same side interior angles. I'm going to do the same thing here. There's my interior, and this time I have one inside and one outside. So it looks like the only option here would be corresponding angles. So I'm going to look at those 4 angles and those 4, and A and B are both the sort of bottom right angle in that bank of 4 angles, and so those are called corresponding angles. And last, I have these 2. There's my interior. So both my angles are interior or exterior. They're outside of those 2 lines. And now I ask myself, are they on the same side or opposite sides of this transversal? Well, they're on opposite sides, so we're going to call those alternate exterior angles. So you've made it to the end. That's it for this lesson. Be sure to write down any questions you might have and ask me any questions you might have when you get the chance.